All right. Greetings, YouTube. Beautiful Mind here. And we have this question that comes from Trigonometry. This comes from our textbook, section 4.4, question 37. It says, a dual beam rotating light on a movie set is positioned as a spotlight shining on a prison wall. The light is 10 feet from the wall and rotates clockwise. The light shines on the point P on the wall when first turned on, where t equals 0. After t seconds, the distance in feet from the beam on the wall to the point P is given by the function shown below. The main thing that we're trying to do here, we're asked to, it says when the light beam is to the right of P, the value is positive. When the light beam is to the left of P, the value of D is negative. We're asked to graph D over the interval as t goes from 0, the closed interval as t goes from 0 to 6, okay? Let me see, will that work? Okay. Okay. Oh, okay. So it gets rid of it. That's fine. Okay. So we're graphing tan, right? So in class, we kind of had this discovery about like basically you do your ABCs, right? So for instance, our A, let's go here. We'll do this color. Our A was our amplitude, right? So we wanted to find the absolute value of A. In this context, it's going to be the absolute value of 10, which is just 10. All right, so we got an amplitude of 10. Okay, so we'll see how that factors into graphing tan. And then the B was given us information about our period. So for this to be tan, the period of tan is going to be what? Pi over B. Okay. So our B in this case, okay, that could be the case. It looks like our B is pi over 6. So then we would do pi over 6, right? So we have to keep change flip, and ultimately we get a period of 6. So it looks like after what, 6 seconds, this graph is going to repeat. Okay. And then lastly, we had our C, which is our phase shift. Now here it looks like we don't have a phase shift. So no phase shift here to account for. So we can just graph it like normal, but instead of repeating every pi radians, it's going to repeat every basically 6 seconds or every 6 units. And we'll see how to factor in the amplitude. So for the graph of tan, okay, so say this is like my positive x, or I guess in this context, my positive t. And then here we have our d of t. Okay, positive d in this direction. Okay. I'm tempted to graph tan like normal. Okay. So tan is like what? It's an odd function. It's symmetric about the origin. It passes through the origin. I want to say at plus or minus 90 or pi over 2, it has asymptotes. But we want this to repeat, let me see, every 6. So say this was our 6 out here. Let me see. Halfway, that would be what, every 3 seconds. And then so each of these tick marks is basically 1.5. Let me think. Okay. So with tan, right? Okay, and then let's capture our amplitude. So amplitude is 10. So I'm just going to put my 10 here. And then another 10, like negative 10 here, right? So the graph of tan, it passes through the origin, right? If we don't shift it side to side at all. And then when we finish at the end of the period, we should be back at 0, right? Y value is 0. So then halfway between the zeros for tan, we should have an asymptote. So right here should be an asymptote. Give me just a moment. So again, for tan passes through the origin. We didn't shift it side to side at all. So this one should start at 0. Let me see. What is it, D? After t seconds, the distance of the beam to the point P, right? So at time 0, the distance to the point P is also 0, right? So again, when we start, it's at 0. When we finish, we're back at 0. For the graph of tan, halfway between our zeros should be an asymptote. And then halfway between that first 0 and the asymptote is going to be our critical number, or, just the amplitude. That's where that gets factored in. So right here, it should have a value of 10. And then on the other side, it should have a value of negative 10, right? And so essentially the graph is going to behave. We start at this point, pass through this point, and then finish close. Start close, pass through the point, and we end there, right? And that's essentially the graph of tan. Okay. I think that's it. Right. So again, takeaways, and we can check. Let's actually check and confirm these numbers instead of just taking it at face value. Let's go like here. Okay. So for instance, if we do a similar window to what we drew, so let's get a copy of the original function first. Okay. I'm going to go to my y equals. Let's put this in. It's already in radians, so we'll go 10 times the tan of, I'll do an open parentheses, pi x over 6. Close off the trig function. Okay. And then to match the window, if that's 10, let's have it go up to, let me see, so our x values, let's go down to like -1 and up to, we can go up to 7. I just want to go slightly past 6. And let's let each tick mark be 1.5. All right, so that way we can match what we have drawn. Because our tick marks, each of our tick marks are 1.5, okay? And then our minimum, if that's a -10, let's go down to like -40. My y minimum, I'll put -40, and then the max is 40. And I want, on the y-axis, I want each tick mark to go by 10, okay? Now, if we just hit graph, it's going to try to connect our graph to the asymptote, so it's going to behave kind of weird. So I'm going to go back to this y equals. It'd be nice if I can get that graph, but I don't think I can get that. But I'm going to change. This from connected. I'm just going to hit enter on this little option here. Keep going. To this dotted version, so that way it won't try to connect to the asymptote. It's not gonna draw the asymptote, but we have to be aware that it's there. I think we're good. So let's go ahead and hit graph. And one other thing we can do to confirm before we graph, I'm going to go to stat, edit, and I'm going to plot these points that we have, right? So for instance, we have the origin when x is what, 1.5, when x is 4.5, and when x is 6. All right, so when x is 0, the corresponding y is 0. When x is 1.5, the corresponding y is 10. Also, we could have, manually checked a lot of these numbers. At 4.5, the corresponding y value looks like it's a -10. And then at 6, the corresponding y-axis is 0. Okay, I'm going to turn these points on. So stat plot, and I got to turn these guys on. The square box is fine. Okay, now I'm going to hit graph. So we can see our points is passing through the points. It's not going to show the asymptote, and it basically passes through our points. All right. Okay. So that's about the best we can do there. All right, and so with that, we're going to go ahead and end the session here. And from one beautiful mind to another, take care and peace.